Welcome to DMAT 0315 for week 14. There are a few topics that I wanted to go over for you this week. Starting with solving an exponential equation by finding common basis linear exponents. Here in this example, we need to solve for x. Note that an equation is exponential because it has variables in the exponent. This equation, 8 raised to the negative x plus 3 is equal to 16. So that we can kind of make it look like something that we know, we need to think of what number raised to a power would give us 8. And the same thing for 16. The key is that they have to have the same base. So 2 raised to the third power is equal to 8. While 2 raised to the fourth power is equal to 16. So we'll substitute those two in. So we'll have 2 raised to the third power raised to the negative x plus 3 is equal to 2 raised to the fourth power. Next, we need to distribute on the left side of our equation. So we'll multiply 3 times the negative x to give us negative 3x and 3 times the 3 to give us 9. So then from there, we can use our laws of logarithms. We will need to use the logarithm of a power rule, which has us to make our exponent become our coefficient. In this case, since our bases are the same, we'll take our exponents and set those equal to each other and solve for the variable. So negative 3x plus 9 is equal to 4. Subtracting 9 from both sides, we have negative 3x is equal to negative 5. Then we divide both sides by negative 3, ending up with x is equal to 5 over 3 because the negatives will cancel each other out. Our next topic is solving an exponential equation by using logarithms, exact answers in logarithmic form. Here we are told to solve for x, write the exact answer using either base 10 or base e logarithms. I chose to use base 10, but you can use base e. Remember from last week, e is equal to 2.7181828 in case you use base e. So here we have 3 is raised to the x plus 10 power is equal to 2 raised to the negative 10x power. Notice both sides of the equation are positive for any value of x. Both bases are positive real numbers, and a positive number to any power will give you a positive number. So, like I said, I used base 10 to solve it. So, we will start off by using logarithms to try to solve this problem. So that's where the log part comes in. If you're using base e, then you would put e raised to whatever the powers are. Then we have the power of a logarithm or logarithm of a power rule. Our exponent is going to become our coefficient. So that's how we get x plus 10 log 3 is equal to negative 10x log 2. So from there we need to distribute log 3. So we're going to multiply that times everything inside of this parenthesis. So x times log 3 is going to give us x log 3. 10 times log 3 is going to give us 10 log 3. Next, we need to get our x terms together because we're trying to solve for x, so it has to be isolated at some point. So that means we're going to need to add negative 10x log 2 to this side, and then we'll need to subtract 10 log 3 from this side so that our x's are together. In doing that, we'll end up with x log 3 plus 10x log 2 is equal to negative 10 log 3. Next, we need to take out our common factor, which is going to be x, leaving us with log 3 plus 10 log 2 times x is equal to negative 10 log 3. To get x by itself, we'll divide everything by log 3 plus 10 log 2, and we'll end up with this answer right here. The next topic is solving systems of linear equations. And we are going to use 3 methods to solve for the systems of linear equations. The first one is solving graphically. You can have 3 possible answers or solutions when solving graphically. You can have exactly one solution, which happens when your 2 lines intersect at one point. That one point is called your solution. The second solution type is infinitely many, which means when you plot the 2 lines, they lie exactly on top of each other, so you could have many solutions. And then the third one is no solution. That happens when your 2 lines are parallel. They never touch, they never cross each other, so you don't have a solution. Here we have the problem y is equal to 1/2 x minus 3 and negative 2x plus y is equal to 0. These are the 2 equations that make up our system. The first thing we need to do is to pick random points for x and then solve for y. Do that for both of the lines so that we can plot them. I did the tables below, and it doesn't always happen this way, but it just happens that the 2 points showed up, negative 2, negative 4, and negative 2, negative 4. So because that's the same in both, we know that that's where the 2 lines are going to cross. When we plot them, we will end up with our 2 lines crossing at negative 2, negative 4, which would be considered as our solution. The second type of systems equation solving method is going to be using substitution. So here's some steps for you to review. Let me know if you have any questions about those, but we're going to walk through them in this problem. This problem has 3x minus 5y equals negative 27, and x is equal to 3y minus 13. So we are going to substitute. In this equation, we know that x is already equal to 3y minus 13. So we can take this 3y minus 13 and plug it in place of the x in the first equation. Doing that, we'll need to distribute. So 3 times 3y gives us 9y, and 3 times negative 13 gives us negative 39. Then we have like terms on this side of the equation. So we'll combine 9y minus 5y, giving us 4y, minus 39 equals negative 27. We need to add 39 to both sides of the equation. We end up with 4y equals to 12, and then divide both sides by 4 so that we can solve for y, getting y is equal to 3. So now that we know that y is equal to 3, we can take that 3 and plug it into either one of these equations to solve for x. So I just chose the second equation. So x is equal to 3 times the 3 that we know from the y, minus 13. Solving that, we'll get x is equal to negative 4. So the solution would be negative 4, 3. The third type is solving a system of linear equations using elimination with addition. In this particular one, we have 4x plus 3y equals to 8 and 4x plus 6y equals to 20. So because this process is called by elimination, we want to try to eliminate one of the variables. For this problem, it would be easiest to eliminate the 4x because both equations have 4x. So if one is positive and one is negative, then that means if we're adding the 2 equations together, they will cancel each other out. So let's just multiply our second equation by negative 1. And mind you, you can multiply either one of the equations by negative 1. You just need one of the 4x's to be negative and one to be positive. So multiplying the second equation by negative 1, we'll get negative 4x minus 6y equals negative 20. Then we want to add the 2 equations together. Doing that, the 4x's will cancel out, eliminating the x term. 3y minus 6y is negative 3y, and 8 minus 20 is negative 12. Divide both sides by negative 3, and y is equal to 4. Since we know that y is 4, we can take that and plug it into either one of our equations. I just chose the first one. And solve for x. So 4x plus 3 times 4, which we know from the y is equal to 4, is equal to 8. Subtract 12 from both sides, we get 4x is equal to negative 4. Divide both sides by 4, we get x is equal to negative 1. So the solution would be negative 1, 4. Here in these systems, we are just going to be working with fractions. So processes are still the same, we just have fractions. So the first thing that you want to do is to get rid of your fractions, because that always makes solving the problems a little easier. So in order to do that, we will need to multiply each equation by its least common denominator, or LCD. For the top equation, the LCD is 4, and the bottom equation, the LCD is 6. So multiplying 4 times this top equation, we will end up with negative 3x plus 8y equals to negative 1. And multiplying 6 times this bottom equation, we'll end up with 2x minus 3y equals to negative 18. Now we need to decide which variable we want to eliminate. So I just chose to eliminate x. So in trying to eliminate x, we need to have one of the x be positive and one of the x's be negative with the same number. In this case, we have a negative 3 and a positive 2. So if we were to multiply the top equation by 2 and the bottom equation by 3, that would give us a negative 6x and a positive 6x, which would cancel them out. So in multiplying 2 times our top equation, we'll get negative 6x plus 16y equals negative 2. And multiplying 3 times our bottom equation, we'll get 6x minus 9y is equal to negative 54. As you can see, our x values will cancel each other out. So we'll have 16y minus 9y gives us 7y, and negative 52 plus negative 54 gives us negative 56. Dividing both sides of the equation by 7, we end up with y is equal to negative 8. So now that we know y is negative 8, we can take it and plug it into either one of the equations that we've come up with. I decided to go back to the second set of equations and pick negative 3x plus 8y equals to negative 1. That way I didn't have to work with any fractions. So plugging in negative 8 for y, we will get negative 3x minus 64 equals to negative 1. Add 64 to both sides and we'll have negative 3x equals to 63. Divide both sides by negative 3 and we get x is equal to negative 21. So our solution will be negative 21, negative 8. That's all I have for today. If you have any questions, be sure to email me. Thank you.